In this video, I'm going to show you how to use Excel to approximate the zeros of a function using intermediate value theorem's idea. So suppose we have f being a continuous function, and we know that f of some value a and f of some value b are opposite in signs. Then according to the intermediate value theorem, f must have a zero in between a and b. Now let's consider the function f of x, which is just the third order polynomial x cubed minus 4x squared plus 4. First, we are going to prepare two columns. One is for x, the other is for the value of f of x. For this function, it is okay to start working with -5, -4, and up to +4 and +5. Alright. Now, on the second column, you type equal, and then you click the cell next to it, then a hat, and then cube, and then minus 4 times. You click on the cell here again, and then a hat, squared, and then plus 4. Basically, you are typing this function into the second column so that it is going to compute the value of the function when x is -5. After you finish typing the formula here, you hit enter. Alright, so this is the value of f of x when x is -5. Now you double click on the lower right corner here. It is going to compute f of -4, f of -3, up to f of 5 for you. When x is -1, f of x is a negative value. When x is 0, f of x is a positive value. So that means there must be a 0 in between -1 and 0. We also know that there must be a 0 in between 1 and 2 because when x is 1, the value of the function is positive, and when x is 2, the value of the function is negative, opposite in signs. And there is also another 0 for the function f from 3 to 4. Alright, for the purpose of the demonstration in this video, I'm going to focus on finding the 0 in between 1 and 2. Of course, you can repeat what I'm going to do to find the 0 in between -1 and 0 and the 0 in between 3 and 4. So let's do that. So first of all, I'm going to copy this, right, to another cell. As I said, I'm going to focus on finding the 0 in between 1 and 2. So in between 1 and 2, we have 1.1, 1.2, alright, and then you just select the first 2 or 3 cells. After you finish the pattern, you double click. That is going to automatically compute the other values for you. And on the right hand side, you see that your values for the function f has been updated. Now, by looking at the value of the function f, we know that f is going to change its sign when x goes from 1.1 to 1.2. So there must be a 0 in between x equals 1.1 and 1.2 by the intermediate value theorem. So up to now, we know that the approximation for our solution would be something like 1.1 something that we are going to find next. So next, we are going to copy the table again, right, to another cell. Now we know that the solution must be in between 1.1 and 1.2. There are going to be 1.11, 1.12. You just need to select the first 2 cells and double click. Alright. Now look at f on the right hand side here. We now know that our solution must be in between 1.19 to 1.2. That is because the value of f of x at x equals 1.19 is positive, but then when x is 1.2, the value is negative, right? So now we are going to copy the table again. And we now know that x must be in between 1.19 and 1.20. Look at the value of the function f. Here it is positive, but the next one is negative. So there must be a 0 in between 1.19 193 and 1.194. Up to now, we know that the 0 must be something like 1.193 blah blah blah. And the next step is to figure out what that blah 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 is. Alright. So next we copy the table again. Alright. We know that the solution must be between 1.193 and 1.194. Alright, now look at the value of the function f here. You have all positive, but then suddenly negative. Now from here, you know that our solution must be in between 1.1939 and 1.194. Okay, let's summarize everything. First, we create a table that consists of several values of the x variable. Then we ask Excel to compute the value of the function f by triggering some function that you see on the top here. By looking at the value of f and using intermediate value theorem, we know that at least there must be a 0 in between 1 and 2. Then we modify the value of x because we want x to be from 1 up to 2. So in the middle, we would have 1.1, 1.2 up to 1.9. By looking at the second table, we know that the value of the 0 must be in between 1.1 and 1.2. Then we create the third table by copy and paste, and then modify the value of x. That starts from 1.1 and ends as 1.2. Looking at the value of the function f again, and we know that the solution or the 0 must be in between 1.19 and 1.2. Then we create another table by copy and paste. Start value 1.19 and ends at 1.2. Looking at the value of the function f again, we know that the 0 must be in between 1.193 and 1.194. Then we create another table by copy and paste again. Right? The first value in the table is 1.193. The second value is 1.194. And the values in between would be 1.1931, 1.1932, blah, blah, blah. And then looking at the value of the table again, we spot out the fact that the 0 must be in between 1.1939 and 1.194. Alright, so up to now, we can say for sure that our 0 must be greater than 1.1939 and less than 1.194. Alright, that means that if you write the 0 down in decimal places, it would be something like 1.1939 ... Alright, so if you want to find an approximation for the 0 that is correct to 3 decimal places, right, then the answer would be 1.194, because the number 9 here would means you have to round up to 4 in the third place after the dot. Alright, so I hope this video helps, and thank you for watching.